Today we are going to learn about mastering Python virtual environments for DevOps. You'll acquire skills to create, manage, and troubleshoot Python virtual environments crucial for DevOps workflows. Welcome to our video on mastering Python virtual environments for DevOps. In today's session, we will dive into what Python virtual environments are and why they are indispensable in the DevOps world. A Python virtual environment is a self-contained directory that contains a Python installation for a particular version of Python, plus a number of additional packages. These environments allow developers to manage dependencies for different projects separately, ensuring that projects have access to the correct versions of libraries. This isolation is crucial in DevOps as it ensures that applications run consistently across different environments, such as development, testing, and production. Understanding and efficiently managing these environments can significantly boost your productivity and ensure the stability of your deployments. In the DevOps landscape, the benefits of using Python virtual environments are manifold. Firstly, they isolate dependencies for each project, ensuring that one project's dependencies don't interfere with another's. This is particularly important when different projects require different versions of the same package. Virtual environments prevent these version conflicts, which can otherwise lead to unpredictable behavior in applications. Additionally, virtual environments facilitate collaborative workflows as they allow teams to easily share environment configurations through files like requirements.txt. This enhances deployment consistency across various stages of development, testing, and production, ensuring that the application behaves the same way on every machine. Moreover, managing environments becomes significantly easier, allowing for quick setup and teardown of development environments, which is a boon in fast-paced DevOps operations. By mastering virtual environments, you can streamline your workflows, reduce errors, and improve collaboration within your team. Now that we understand the benefits, let's move on to setting up a virtual environment using Python's built-in venv module. The venv module is a simple yet powerful tool for creating lightweight virtual environments. To create an environment, you can use the command python mvenv myaf, where myaf is the name of your environment. This command will create a directory with the same name containing a standalone Python installation and a few other resources. Once created, you need to activate the environment using the command source myaf/bin/activate on Unix or myaf/scripts/activate on Windows. Activation modifies your shell's path so that it uses the environment's Python executable and installed packages. When you're done working, you can deactivate the environment with the deactivate command, returning your shell to its previous state. Understanding the directory structure created by venv is crucial for managing the environment effectively. The structure typically includes folders for binaries, libraries, and the Python interpreter. Mastering these steps is fundamental to managing isolated environments efficiently.
Once you have a virtual environment set up, managing dependencies is the next step. The primary tool for this task is pip, Python's package installer. To install a package, use the command pip install package_name. It's important to note that when your virtual environment is active, pip installs packages only within that environment, ensuring isolation. For managing multiple dependencies, it's common to use a requirements.txt file. This file lists all the packages and their versions needed for your project. You can generate this file using pip freeze greater than requirements.txt, which captures the current state of your environment's dependencies. To install these dependencies in another environment, simply run pip install or requirements.txt. Keeping your packages up to date is important, and you can upgrade a package using pip install upgrade package_name. Similarly, to remove a package, the command pip uninstall package_name is used. Mastering pip is essential for effective dependency management, ensuring that your DevOps workflows remain smooth and error-free.
Maintaining effective isolation of your Python environments is crucial for consistent application performance. Here are some best practices to follow. Firstly, create a separate virtual environment for each project. This ensures that projects are completely isolated, preventing dependency clashes. Keep your dependencies minimal, only include packages that are absolutely necessary for your project. This reduces the risk of conflicts and makes environments easier to manage. Regularly update your requirements.txt file to reflect the current state of your environment. This documentation is invaluable when setting up environments on new machines or when sharing with team members. It's also a good practice to document your environment setup process, including steps to recreate the environment, which aids in transparency and collaboration. Lastly, avoid global installations of packages unless absolutely necessary. By sticking to these practices, you can maintain clean, manageable, and reproducible environments that ensure your DevOps workflows are efficient and reliable.
Deploying applications within virtual environments ensures consistency across different deployment stages. One key aspect is managing environment variables, which can be done using a .env file or similar methods to keep sensitive information secure. When deploying, it's important to activate the virtual environment and ensure that all dependencies are installed in the production environment. Using tools like venv, you can replicate the development environment in production, minimizing discrepancies. Integrating virtual environments with C/CD pipelines is another critical step. This integration allows for automated testing and deployment, ensuring that code changes don't break the application. Before deployment, rigorous testing within the virtual environment is essential to catch any issues early. By following these steps, you can ensure that your applications are deployed smoothly and operate consistently across all environments, providing a reliable experience for users. Despite best practices, issues may arise with Python virtual environments. Common problems include package conflicts, which occur when multiple packages require different versions of the same dependency. To resolve this, carefully check the requirements.txt file and adjust package versions as needed. Activation errors can occur if the environment paths are not correctly set. Ensure that the activation script is executed properly and that your shell is configured correctly. Broken dependencies might result from missing packages or incorrect versions. Running pip install or requirements.txt can help resolve these issues. If you encounter path-related problems, verify that the environment paths are correctly set in your system's path variable. Utilize error logs to gain insight into issues, as they often provide detailed information on what went wrong. By systematically addressing these common issues, you can ensure that your virtual environments run smoothly, reducing downtime and maintaining your DevOps workflows efficiently.
Automating the setup of Python virtual environments can save significant time and reduce errors. Shell scripts are a powerful tool for this task, allowing you to automate the creation, activation, and setup of virtual environments. By incorporating environment setup scripts into your C/CD pipelines, you ensure that environments are consistently and reliably set up for each deployment. Scripts can automate the installation of dependencies by including commands like pip install requirements.txt, ensuring that all necessary packages are installed without manual intervention. Additionally, scripting the activation and deactivation of environments can streamline your workflow, making it easier for team members to get started with development or testing. Ensuring reproducibility is crucial. Your scripts should be well documented and version controlled to maintain consistency across different setups. By mastering automation, you can optimize your DevOps processes, reducing setup time and minimizing human error.
Integrating Python virtual environments with Docker combines the benefits of environment isolation with containerization. Docker enables consistent application deployment across different platforms by encapsulating the application and its dependencies in a container. A Docker file is used to define the environment, specifying the base image and the commands to set up the application, including activating a virtual environment. Managing dependencies within a Docker container is similar to managing them in a virtual environment. You can use pip install to install packages. Docker ensures environment isolation, as each container runs independently, preventing conflicts. Docker Compose can further simplify managing multi-container applications, allowing you to define and run complex setups with minimal effort. By understanding how to integrate virtual environments with Docker, you can enhance the portability and scalability of your DevOps workflows. Security is a paramount concern when managing Python virtual environments. One key aspect is securing environment variables, which often contain sensitive information such as API keys or database credentials. Use tools like .env to manage these variables securely. Managing access permissions is crucial. Ensure that only authorized users have access to the environment and its configurations. Regularly updating dependencies is another important practice, as outdated packages can have vulnerabilities that expose your application to risks. Always use trusted sources for downloading packages, and verify the integrity of the packages before installing them. Monitoring your environments for vulnerabilities can be done using tools like Safety or Bandit, which scan your dependencies for known security issues. By prioritizing security, you can protect your applications and maintain the trust of your users.
In conclusion, mastering Python virtual environments is a crucial skill for anyone involved in DevOps. We've covered the essentials of what virtual environments are, their benefits, how to set them up and manage dependencies, best practices for maintaining isolation, deploying applications, troubleshooting common issues, and even automating environment setup. Understanding these concepts will empower you to create robust, efficient, and secure DevOps workflows. As next steps, I encourage you to apply what you've learned by setting up your own virtual environments and experimenting with different configurations. There are numerous online resources and communities where you can expand your knowledge further. Remember, practice is key to mastering these skills. Thank you for joining us, and happy coding!